Okay, so this is the Unit 1 revision video going over the March 2011 Unit 1 higher paper. So let's look at the first question. Dan is doing a survey to find out how much time students spend playing sport. He's going to ask the first 10 boys in the register for his PE class. This may not produce a good sample for Dan's survey. Give 2 reasons why. These reasons can be anything to do with the following reasons. 1. The bias relating to only asking the same age group. 2. Bias relating from only asking boys. 3. A bias relating to only asking PE students. 4. That the sample size is too small. Or 5. It's not a random survey. So part B. Design a suitable question for Dan to use in a questionnaire to find out how much time students spend playing sport. Now a suitable question for this is going to ask something about how many hours do you play sport, and the key thing is to have some sort of time frame in there. So per week we would need to put in there to get the mark. Now for this kind of question we want some answers. So we need at least 3 boxes. We can always use more, that's fine. And they must not overlap. So the first one might be 0 to 2 hours, 3 to 5 hours, 6 to 8 hours, 9 or more hours. So in question 2, we're asked to plot a point on this scatter graph when there are 11.5 hours of sunshine and 73 ice cream sold. So we go on to 11.5 up to 73, and we just put a point on our graph. Okay, then part C asks us, one day had 10 hours of sunshine, estimate how many ice creams were sold. To do this, we need the line of best fit, trying to get a roughly even number of points on both sides. Then when we've done that, we can simply read off from 10 hours the number of ice cream sold, and if we get any answer between 62 and 70, we'll get the marks for that. Okay, question 3. A shop sells freezers and cookers. The ratio of the number of freezers sold to the number of cookers sold is 5 to 2. If the shop sells a total of 140 freezers and cookers in 1 week, A, work out the number of freezers and the number of cookers sold that week. So we know the ratio is 5 to 2. So in total there are 7 shares. So each share individually is worth 20. So the number of freezers, well, that's got 5 shares, which is 5 up to 20, which is 100. And the number of cookers, well, that's got 2 shares, so 2 times 20, which is 40. Part B then. Jake buys this freezer in a sale. The price of the freezer is reduced by 20%. Work out how much Jake saves. So the original price of the freezer is £145. 10% of this is £14.50. So 20% is £29. So he actually saves £29. A teacher asked 30 students if they had a school lunch or a packed lunch, or if they went home for lunch. So we want to work out the number of students who had a packed lunch. Now the easiest way to do this is in a 2-way table. So we know we've got boys and girls, and we've got school lunch, packed lunch, or home lunch. And of course we've got our totals. So let's start putting this information in the table. We know that in total 17 of the students were boys. 17 boys. 4 of the boys had a packed lunch. So 4 boys had a packed lunch. 7 girls had a school lunch. 3 of the 5 students who went home were boys. So we've got 2 bits of information there. There were 5 students who went home, in total, and 3 of these were boys. So now we have enough information to finish filling in the table. So 3 add something equals 5, that's going to be 2. 4 add 3 add something is 17, this has to be 10. 10 add 7 is 17. We know in total there were 30 students, which means 17 add something add 5 is 30, so that's going to be 8. 17 add something is 30, this is going to be 13. And 4 add something is 8, that's going to be 4. So the number of students in total who had a packed lunch is just 8. Question 5. The probability a seed will grow into a flower is 0.85. Lauren planted 800 seeds. Work out an estimate for the number of these seeds that will grow into flowers. So she's planted 800 seeds. The probability they grow is 0.85. Multiply the two together, and we should just get 680. So 680 seeds are likely to become flowers. Question 6. There are 15 bags of apples on a market stall. The mean number of apples in each bag is 9. We want to work out the number of apples in the 15th bag. To do this, we need to know, first of all, how many apples there are in total. So we have 15 bags with an average of 9 apples. So 15 nines are 135. Now we need to know how many apples were in the first 14 bags. So 2 bags had 7 apples. That makes 14 apples. 3 bags had 8 apples. That's 24 apples. 3 bags had 9 apples. That's 27. 4 bags had 10 apples. That's 40. And 2 bags had 11. It's 22 apples. So in the first 14 bags, if we add these up, that comes to 127. So how many were in the 15th bag? Well, that would be the total number of apples. Take away the number of apples in the first 14. 8 apples in the last bag. Question 7. Okay, we want to work out the number of teachers who had a travel time of 35 minutes or more. Well, the upper quartile was 35. This means that a quarter of the teachers travelled for more than 35 minutes. So a quarter of 48 is just 12. 12 teachers. Part B, draw a box plot. So we know the least time is 5. We know the greatest time is 47. We know the median is 28. The lower quartile is 18. The upper quartile is 35. Then we just got to turn the middle lines into a box and join up the last bits. There's our box plot. Okay, we're then asked to compare the two box plots. Well, if we can look at both of them at the same time, you should see that the median for Tuesday is higher, which means then that on Tuesdays the journeys took longer on average. And we also see that on Tuesday the interquartile range is greater, or there was a greater variation in the travel times on Tuesday. Question 8 is a functional maths question. So we want to know if it's cheaper to stay 3 nights in June or 4 nights in November. So in June then, the cost of staying in the hotel room, well, that's 74.25 per person. There's 2 people and they're staying for 3 nights, which is £445.50. The cost of 2 people eating dinner for 3 days is £186. Add those two together and we get £631.50 in June. So let's work out again for November. In November we got this discount that 3 nights is for the price of 2. So if they then stay an extra night, essentially they're getting 4 nights for the price of 3. So we have 2 people staying for 3 nights at £59.75, which works out as £358.50. And we have 2 people eating for 4 days at £31.75, which is £254. So in total, this comes to £612.50. Therefore, it's cheaper to go in November. And it really is important to have that final phrase. The examiners are looking for you to come to a conclusion, to say that it is cheaper in November. Okay, so we now want to work out the value of x in this probability table. Now we know that if we add all the probabilities up together, they should add up to 1. So if I add all these, what I end up with is 4x plus 0.76 equals 1, which means that 4x equals 0.24, which I can work out to be that x equals 0.06 by dividing by 4. So Mary plays the game twice, work out the probability of her scoring a total of 8. Well, how can she score 8? She can get 3, then 5, 4, then 4, or 5, then 3. The probability of getting 3, then 5 is going to be 0.16 times by 0.3, which is 0.048. Probability of getting 4, then 4, that's going to be 0.21 times 0.21, which is 0.0441. Probability of getting a 5, then a 3, that's 0.3 times 0.16, 0.048. So in total then, adding those up, the probability is 0.1401. Okay, now we're asked to estimate the mean weight of an egg from this grouped frequency table. What we need here is we need a column for the midpoint of the interval. So halfway between 0 and 30 is 15. Halfway between 30 and 50 is 40. Halfway between 50 and 60 is 55. Halfway between 60 and 70 is 65. And between 70 and 100 is 85. Now, just like a normal frequency table, we're going to multiply the frequency by the midpoint. So we get 0, then we get 560, then 880, then 1365, and 765. So the total then is 3,570. So the mean 3,570 divided by the number of eggs, which is 60, 59.5 grams. We're then asked to plot a cumulative frequency, or finish the cumulative frequency table. So this is just going to be up to here, up to 50 we have 14, up to 60 we've got 30, to 70 we've got 51, and then 60. We then just need to plot these on a cumulative frequency chart. Next, cumulative frequency chart next. So now we're going to plot these on a cumulative frequency graph. Point here. Okay, so we can now just join these up, hopefully in a nice smooth curve. And then we want to use our graph to find estimate for the number of eggs with a weight greater than 63 grams. Well, if we use a ruler and go up from 63 grams and read across, we see there that's about 39. So 39 had a weight less than 63 grams. There were 60 eggs in total, so 60 take away 39. There are about 21 eggs with a weight more than 63 grams. If you go anywhere in that region, you'll get the marks. Okay, now we just need to fill in this probability tree. So probability should always add to 1, so 0.8 plus 0.2 makes 1, 0.6 plus 0.4 makes 1, and then underneath should be the same as above. So then the probability that they both don't bring a calculator, well, that's going to be 0.2 times 0.4, 0.08, the answer for part B. Question 12 then, we're doing stratified sampling. We want to know how many male students who choose climbing we should ask. Well, we're taking a sample of 50 out of possible 182, and there are 34 male climbers. So if we work that out, 50 divided by 182 times 34 is about 9.34. So we should ask 9 students.